Well, greetings everybody. I got a question today about open versus closed points on graphs, and I'd made a video about that already, but I thought I could make one that is maybe a little slower and goes into more detail about it, and hopefully that will clear everything up. So what I'm talking about when I bring up this issue of open versus closed points on a graph is something like this, okay? So notice, like, I'm supposed to in this question choose which graph is correct, and I notice if I look at any of them in detail that there are lines that sort of merge in the middle, and this one has an open point and this one has a closed point. So like this line goes right up to that point, but then that point is intentionally drawn as an open circle, and then this line goes right up to that point where that point is intentionally drawn as a closed circle. What's the difference? Okay, so let's talk about that. So I'd like to always, when I teach math, I should provide you with a lot of detail, because depending on what ultimately you want to do with your education and career, you might need to know a lot of the details behind all this, okay? But I will also give you the short answer. So open versus closed points on a graph, the short answer is an open point is always associated with a less than or greater than sign, and a closed point is always associated with a less than or equal to or a greater than or equal to sign. So these are inflexible absolute rules about how and when you find open and closed points on a graph. So let me show you how. Okay, so let's graph this one. So we'll start small. I won't do like the whole problem that I have in mind yet. I'll start small and show you this one. How can we graph y is equal to x plus 4 if x is greater than or equal to 2? So I might take the approach of making a table in order to draw the graph. The reason is because the table will give me some points, and the graph is made of those points and the overall pattern that is indicated. So on my table, I choose x to be 2, 3, and 4. Why would I do that? Well, because the instructions were we're going to graph this equation, but only if the x is greater than or equal to 2. So that means 2 is okay, and anything bigger than 2, greater than or equal to 2. So I choose 2, 3, and 4 in order to abide by greater than or equal to 2. And if I put 2 in there for x, what is 2 plus 4? That would be 6. If I put 3 in there for x, what is 3 plus 4? That would be 7, and so on. Now, if I take these points and I plot them on a graph, here you see a graph, then I got 2 and 6 right there, 3 and 7, 4 and 8, and I see those 3 points are right along a line together, and I drew a line through those 3 points, and that's the graph, okay? Now, that point right there, 2 and 6, that should be closed. So why is that? 2 reasons. I'll tell you 2 reasons why this point right here should be closed. I said, well, closed points are always associated with less than or equal to or greater than or equal to. Notice my instructions here say x is greater than or equal to 2. That alone would tell me that the point is closed. Okay? The point associated with the end of that graph is going to be closed just for that reason. Another reason why we can say that point's closed is because that point, just like all the others I've drawn there, do you see this dot right here? See, that's a closed point, in this one. You know, they're all closed. Why is that? Well, because they're actually on the graph. You know, it's like it says x is greater than or equal to 2. Okay, 2 is allowed. 3 is allowed. So all those points are allowed. I can plug them in according to these instructions and plot them on the graph. Okay. Well, what's not allowed? Like, well, could I put 1 in? No. I mean, could 1 be on this table? No, because why not? 1's not greater than or equal to 2. Could I put 0 or -1? Okay, so I can't put any of those points in. Now, that also tells me that the graph stops here at that point. It doesn't keep going. I know that we see these 3 points from my table indicate a pattern that is a line, but that line cannot go past this point right here off in this direction. Why is that? Well, because the instructions are that x is greater than or equal to 2. So that means like the graph is only from x 2 to the right. See? It doesn't go past that point. All right. Now let's compare that with this one. How can we graph y is equal to 4 minus x if x is less than 2? So again, I take the approach of making a table and getting some points and using those points to see what the overall pattern is and then draw the graph from there. So, well, what would we choose? X less than 2. Well, I could choose 2, 1, 0. Okay. X less than 2. Numbers smaller than 2. 2, 1, 0. So why not 3? Why not 4? Nope, those are no good. X is less than 2. We're going to stick to that. So I choose 0, 1, 2 to abide by that. And I put those x's in here. 4 minus 0 is 4. 4 minus 1 is 3. 4 minus 2 is 2. So those are my points. And I plot the points over here. Now, this time, that point right there, 2 and 2, is open. Okay? Why is that? I'll give you 2 reasons once again. Open points are always associated with less than or greater than. And here in my instructions, I have that the x is less than 2. So this indicates that there's an open point there. So like this point right here, would have to be open. You know, the point where it says x is less than 2, the point at the 2 has to be open. That's just how it goes. So I drew it open like that. The other points are filled in though. Okay. All right. So that's one reason. One reason why I know that point's open is because, well, that's just the rule that I gave you. Open points are associated with less than or greater than. That's why. Is there a deeper reason? Yeah, there's a deeper reason, and you should think about it, and I should tell you about it. Am I like breaking the rule to put 2 on this table? Like, because my instructions are x is less than 2. Is 0 less than 2? Yes. Is 1 less than 2? Yeah, that's okay. Is 2 less than 2? It's not. All right. So for me to put 2 on this table, I'm not exactly following the instructions. Okay. And so that's why it's open. Well, you might say also, well, if 2's not allowed here, why did you put it? The answer to that is we do that so we can figure out where the graph ends. Okay. All right, because like that, if I say x is less than 2, what's the closest number to 2? 1.99999? I'm not going to put a number like that on the table. There's no need to. I'll just put 2, even though I'm not supposed to do that. See what I get, and just remember that the point will be open there. All right, so that's how we can think about these like in separate cases. All right, so I did 2 examples. Okay. One with a greater than or equal to, one with a less than, and I showed you how that differentiated having an open and closed point. Okay. One more thing, why do I say that the graph stops here? Because when I plotted these points, I saw 3 points that looked like they were right along a line, suggesting the graph was a line. Why does it stop here? Why doesn't it keep going? Well, because the instructions say that the graph exists, or it's found when x is less than 2, so that means the graph is only like out here. It only goes to the left. It doesn't go past that point. So that point where the graph stops is open. In this case, it goes no further than that. All right, so we can think about these two in a similar way. All right, and we can understand the difference and recognition between open and closed points. Now, how would we do something like this? Or this doesn't exactly look like it's as simple as the problems I just showed you. But all anything like this is called a piecewise function, is a combination of 2 simpler functions. Okay, so like here's an example. Like, How would I graph this? Y is equal to x plus 4 if x is greater than or equal to 2, and y is equal to 4 minus x if x is less than 2. How would I graph that? Well, I've actually already done it. I have done these individually. I have graphed x plus 4 if x is greater than or equal to 2, and I have already graphed y is 4 minus x if x is less than 2. All this is the combination of these. So if we can agree that this graph is correct for this equation all by itself, and if this graph is correct for this equation all by itself, then combining those together would be correct for this one. That's it. That's all there is to it. So if we saw anything more complicated like this one, we could just think about these individually, considering on top of that which point should be closed and which point should be open. So what you're looking at here is nothing but this line, those points on it, and this line with those points on it. Okay, so from there, if I was doing a question on my math lab, let's say, I could, if I wanted to, sketch this out on paper in the way that I just showed you, graphing these individually the way that I just showed you, and then if I had it on paper I could figure out which one was correct. Okay, now I'll leave that to you for this particular problem, but that's how we can address the initial question of just looking at the answer, the graph, whatever it is, and noticing the difference between an open point and a closed point.